In this question, in part A, we are to explain why the applied force does not cause the mass to accelerate or to speed up. Now, what are we given? We are told in the question that the object moves at the steady speed over here when the applied force is 12 newtons. Now, for something to move at a steady speed means that the object does not have any acceleration. And no acceleration by Newton's second law means that the forces are balanced, the resultant force is zero. So the applied force of 12 Newton must face an opposite resistant force of the same value, which is also 12 Newton, for the forces on this object to be balanced. So this is the reason why the object does not speed up even when the pulling force is pulling with 12 Newton. It must mean that forces are balanced and there is a backwards frictional force acting on the object, which is also 12 Newtons in the backwards direction. For part B, it's a calculation question. Now you are told that this pulling forward force increases to 18 Newtons for some time. And first up, calculate the acceleration. So we are going to use Newton's second law later on to calculate the acceleration. This also tells us that we need the mass value and we need to find the net force or resultant force value before we can find the acceleration in part 1. So in all calculation questions for Newton's second law, always remember to define the positive vector direction. So I will let the forward direction to be positive, and I will go back to the previous scenario to figure out or to just write down what exactly is the frictional force acting on this object. With a steady constant speed, the frictional force must be of the same value but opposite in direction to the forward pulling force of 12 newtons in the first scenario. So I figure out that the frictional force must be therefore 12 newtons in the backwards direction. Then I'll go on to the new scenario in part B to figure out what is my resultant force over here. And I do this by literally summing up all the forces acting on this block, all the horizontal forces, which involves the driving force and the frictional force. I'll plug in the value, so the driving force now becomes 18 Newton, positive because it's acting forward, and I add it to a negative frictional force. Frictional force is negative 12, negative because frictional force is acting towards the left, and towards the left represent it with a negative vector, so the frictional force is negative 12 newtons. So we got a resultant force of 6 Newton, and plugging the 6 Newton into the second law equation, I can then figure out what is the acceleration. In part 2, we are to calculate the highest speed reached, so this becomes a kinematics question. We have to use the formula for acceleration. If you recall, acceleration is calculated by using the final velocity minus initial velocity divided by the time interval. So rearranging the equation, you can determine what is the final velocity, and that's how I can get 0.9 meter per second. Now, one more thing to note, always keep your answer to the least significant figures. Never ever keep your answer to 1 SF. So for example, in the final answer, if you have written 0.9 meter per second, you are committing a SF or significant figure error. In the acceleration answer, if you have written 2 meter per second squared, you are also committing a SF error. So please don't do that.